Back to limits here in the second part of 12.1. So we saw the idea of a limit in our last video was what happens as you approach a particular value of x on a graph. What's the y value doing? What's the function doing? And the reason this is a question is that sometimes there are holes or asymptotes, weird things can be happening in a graph where we actually can't reach a particular value. So as simple as this, I can't reach an x value of 0. I can never get there because that's undefined. So I'd be questioning, okay, I could say what's happening if I come from the right, what's happening as I come from the left. And we saw that if those two things, those two individual limits are the same thing, then we have an overall limit. What is happening as I approach 0? So that's why we have to ask this question, is sometimes there are places we can't get to. And now we're going to see more applications of the limit as you dive deeper into calculus. But this is the idea. So what's happening is we get very, very close. Now, if we had a graph, it was pretty easy. All you had to do is say, okay, I'm coming from the left, or okay, I'm coming from the right. Pretty easy to see, you just had the picture. But what if I don't have the picture? All I have is the function. Now, we've got a weird one here that's going to involve a sine function being divided by 3x. So the sine function is obviously it's making a wave, but we're dividing that sine function by something we cannot put in 0. That would break the graph. We are not allowed to have 0 down there. It's undefined. So we're going to have to see what would happen. Now, we could graph this thing and we could see. I think it'd be a pretty crazy looking graph. But what we want to do is we want to do this without having the picture. We want to do this from a table. Now look what we're going to do. We're going to build a table that gets closer and closer to 0, and we're literally just going to crunch the values. So don't you see I've got values here that are getting progressively closer to 0. Now I can't do 0 because 0 is undefined, but I could choose numbers that are very, very close to 0. So first of all, I've got negative 0.1, then I've got negative 0.01, negative 0.001, and the same thing from the other side. Now, look what happens as we just simply crunch those numbers. I would put in negative 0.1 in for x, both here and here. And I would just crunch this on my calculator. I would be doing 5, so just to make sure you're with me, 5 sine of negative 0.1 divided by 3 times negative 0.1. Now be careful if you're doing this on how you do your brackets or your parentheses on everything. If you're doing this in one shot on a TI-84 or whatever, be careful. You got to make sure you're dividing the right things. But if you crunch that, just put that in. What the value is 1.66389. Now we would do it again by putting in 0.01, negative 0.01, and we get a value. And as we get very, very close, look what's happening. We're stabilizing. We are approaching a fixed value of 1.66, which is 5/3. We are approaching that. Now, we could keep getting closer and closer and keep doing this, but we already see that we're stabilizing here at a particular value for the function. And if we do it from the right, the exact same thing occurs. We begin to stabilize, and look, it's the same number. From the left or from the right, we're getting the same number. So even though we have a hole here, or an asymptote, something's going on here at 0, from the left and from the right, we're receiving a value of 5/3. So we literally just crunched it manually. We just took a wrench and just did it ourselves the hardest way you could, but we found that we are approaching a particular value from both directions. Okay, so we had a left-handed limit and a right-handed limit, and they're the same thing. So we have a limit, a general limit. As we're trying to reach x, no matter how we're trying to get there, this function is going towards 5/3. All right, now same thing here. So we're going to do this again. We're going to build us a table. Coming from the left, again, I'd recommend, I mean, you could do any numbers you want, but negative 0.1, negative 0.001, that worked for us before. We're going to come from the left, we're going to come from the right, we're going to see what happens. Now pause this if you want to try this on your own, but I'm going to just make the table magically appear here. So we are getting closer and closer and closer from the left. And as we do, look what's happening. We're not going to get there, but we are approaching 5. Now, as we're coming here, coming from the right, as we're getting closer and closer and closer, looks we're stabilizing. So we are approaching 5. I know we can't get there, but we're getting very, 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 very close. And if we pick smaller values and smaller values, we would keep getting very, very close to 5. Now, we're approaching the same number from both sides, so our limit here is 5. Now, a weird thing can happen. Now, as is often the case in these higher level books, there's not a ton of examples. So I hope that makes sense. There's the concept. Now, a weird thing can happen in this last example that we're going to look at. Suppose we tried to graph this. Obviously, there's a problem here with that x on the bottom. Now, it's inside of a sine function. So this is very strange. It's not like just 3 sine of pi all over x. The x is inside the actual sine function. So we're going to get something very odd. If we tried to graph this, now we could have done the table approach, and you'll see the same thing actually. If you tried this, yeah, we're saying they didn't write the notation here, but we're trying to approach 0. Okay, so we're trying to get closer and closer to 0. What would happen? Well, you could try this on your calculator, and what you'd find is something very odd. Look at the picture here. As you zoom in around 0, it doesn't just stop and approach a value. It keeps oscillating, and it actually oscillates forever, infinitely up and down. It actually never approaches anything. And you could do this manually with the calculator, and you would see that your table, as you get closer and closer, isn't doing anything. You just keep getting random numbers up and down and up and down. The oscillation here never ends, and as you get closer to 0, it just keeps oscillating like crazy, and it never approaches anything. So from the left it doesn't exist, from the right it doesn't exist, and obviously then from both sides coming together it doesn't exist. Okay, so now I didn't graph this, I probably should have, but it's going to be exactly the same idea. All they did was change the value that's here. This was pi, but it's still a number. This is 2, it's still a number. So you're actually going to get the exact same thing is going to occur. You can try this on your calculator and try, okay, I'm going to try x is negative 0.1, and I'm going to do negative 0.01, negative 0.001. And you're just going to keep getting random numbers. They don't fit a pattern. And you could come from the other side. You could be coming from 0.1 and 0.01 and 0.001. And it doesn't matter. You just keep oscillating. You don't get a pattern. And so the limit here does not exist. Okay, so that's the approach if you just literally want to just take a wrench and just try to crank on it and try to figure out how you're going to fix this thing, how you're going to find where it's going manually because you don't have the picture.